So how does DecisionPoint scale cost-effectively to reach a mass audience? At the heart of this is a technology called Advanced Cooperative Processing. And this is the way in which DecisionPoint intelligently uses the processing power available to it, right from the data source, the DecisionPoint server, and through to the client devices used by business users, so their tablet devices and desktop PCs too. With Advanced Cooperative Processing, DecisionPoint pushes the processing down as far as possible onto the client. After all, these are powerful devices, so why not make use of that power to reduce the load on the DecisionPoint server? And this really is the key to how DecisionPoint scales, because it means we can deliver fast, consistent performance for business users on their client device, at the same time giving you a BI system that scales so you can share business insights with large numbers of frontline decision makers within your organization. So let's take a look at how Advanced Cooperative Processing works. First of all, let's consider a regular data set. And here we're typically talking about an extract of less than 100,000 rows and pulling back data from a SQL database, an OLAP cube, a local data source, or an SAP business object system. Now, a business user is going to view this information on their client device, be that a tablet or a desktop PC. But sitting between the client and the data source, we have the DecisionPoint server. And when DecisionPoint retrieves data from the data source, that can either be requested on demand or more likely on a periodic basis, in which case we will cache the data on the DecisionPoint server so it's ready whenever a business user needs it. So the business user would open up their interactive dashboard or BI application from their client device, and the client device would request some data from the DecisionPoint server. With a regular dataset, DecisionPoint would return the entire cache of data down to the business user's client device. So all the data required is stored on the client. And that means as the user interacts with their BI application, all that interactivity, as they drill through, as they filter, as they sort, as they pivot, as they get answers to their business questions, it's all happening locally on their client device. There is almost no load whatsoever on the DecisionPoint server. So this means DecisionPoint can scale to support very large user communities whilst delivering fast, consistent response times to the business users on their client devices. So compare this to how many BI tools are architected today. Typically, you have to inhale the entire data source into a vendor's proprietary data storage, meaning you're faced with data duplication, and you're probably going to have to write proprietary ETL tool scripts to get that data into the format required by the BI vendor. And then when a business user wants to access their BI application, every time they interact with their data, so every click, every time they want to drill, every time they want to filter, this results in a round trip back to the server to fetch more data. So all the processing is really taking place on the server. And as you start to increase the user base, you can see that the loading on that server starts to increase dramatically. And this type of BI architecture, which was designed in the pre-mobile era, has inherent limits on its scalability. And if you compare this to DecisionPoint, where we're pushing as much of the processing as possible down to the client and dramatically reducing the load on the server, then you can see that this is one of the reasons why DecisionPoint scales to support very large user bases from commodity hardware. But how does DecisionPoint handle larger data sets? Well, even when we work with large data sets, we tend to refresh that data on a periodic basis and cache the results on the DecisionPoint server. And then when a business user opens a BI application that is built against one of these larger data sets, their client application still requests data from the DecisionPoint server, but the DecisionPoint server just returns a subset of data from the cache down to the local client. This subset of data typically contains some summary level information and one or two levels of drill down. At this point, the user can still interact with their data, and all the interactivity is still happening locally on their client device, putting no loading on the server whatsoever at this point. And as the business user navigates through their data and gets down to the lowest level of detail, well, at this point, the client will request more data from the DecisionPoint server, and the DecisionPoint server will return a new subset of data back to the client, but focused solely on the area under investigation. And at this point, the business user is free to continue their investigation to get answers to their business questions, all the while working locally on their device. And should they need to get down to a lower level of detail, or to switch to another area of the day to continue their investigations, then again, the client will go back to the DecisionPoint server and request a further subset of data at this point. So a key thing is that once a subset of data has been downloaded onto the client device, all the business user's interactions take place locally without putting any further load on the server. And this allows us to achieve a happy balance between fast, predictable response times on the client for the business user, whilst allowing them to roam over very large data sets, and at the same time minimizing the load on the DecisionPoint server to ensure that you have a highly scalable BI system. So we've looked at large data sets. The final area to consider is how DecisionPoint works with big data databases. Well, the good news is that DecisionPoint was designed from the ground up to work effectively with big data. When we work with big data, we dispense with the DecisionPoint cache so we can take full advantage of the power and scale of the big data appliance. So when a business user opens a BI app that is built against a big data data source, the client still goes to the DecisionPoint server to request the data it needs. The DecisionPoint server then dynamically formulates a request to the big data database, asking it for some summary level information and for 1 or 2 levels of detail. The big data database returns that subset of data to the DecisionPoint server, which in turn passes this data straight through to the client. So at this point, all the data that the business user needs is once again stored locally on their client, so they can interact with it in the same way as they can with data from any other source, but ensuring great performance on their local device and minimal loading on the DecisionPoint server. And just as when we're working with large data sets, as the business user navigates through their data and they want to drill into lower levels of detail as they seek answers to their business questions, then the DecisionPoint client goes back to the DecisionPoint server, and the DecisionPoint server dynamically generates these intermediate requests for more data. So the IT team create a query that defines the entirety of the dataset required from the big data database, and then the DecisionPoint server intelligently rewrites this query to just fetch back the subset of data required by the client at any one point in time, without the IT team or the BI designer needing to do any further work. This offers a huge productivity gain over other tools which expect you to hand code all of the intermediate queries. And it also means that DecisionPoint takes full advantage of the power of the big data database without having to duplicate that data into a proprietary in-memory database, which many BI tools require you to do, and in which case you lose the power of the big data database. So the DecisionPoint server passes the dynamic request for more data to the big database, and the big data database passes back the requested subset of data to the DecisionPoint server, which in turn passes this data straight through to the local client. And at this point, the business user can continue to navigate through their data, again working locally on their client machine with no load on the DecisionPoint server. And in this way, we can deliver fast, consistent performance for business users on their client device, whilst enabling them to roam over a potentially enormous data set, and all that time putting minimal load on the DecisionPoint server. And this is what enables DecisionPoint to scale to support very large user communities. So what you've just seen is how DecisionPoint scales to support potentially tens of thousands of business users from commodity hardware. And the key to it all is Advanced Cooperative Processing, which pushes as much of the data processing as possible down to the client device. And as we've seen, this minimizes the load on the server, which allows the DecisionPoint server to support a much larger user community, but also critically ensures that we deliver fast, consistent response times for our business users. We've also seen how DecisionPoint can work against standard data sources like SQL databases, OLAP cubes, local data sources, and even SAP business object systems. In these cases, we use the server caching and scheduling to deliver the best performance. But when we work against a big data database, we leverage the full power of that system by passing data straight through from the big data database to the DecisionPoint client. Taken together, this results in an architecture which is far more scalable than traditional business intelligence architectures, and can support much larger user communities from much lower cost hardware.